Hello friend, first upon thanks to Professor Sachin Hatkar sir to give me this opportunity. My name is Nikhil Vijaykumar Maske, studies in B.SC third year, Others College Hingoli, under the University Swami Ramananda Tirth Marathwada University Nanded. So I will prove this theorem. Part A. If a set is linearly dependent, then any subset of it is also linearly dependent. Part B. If a set is linearly dependent, then any superset of it is also linearly dependent. Statement of this theorem. In a vector space V, suppose V1, V2 dash dash Vn is an ordered set of vector with V. The set is linearly dependent if and only if one of the vector V2, V3 dash dash Vn from say Vk belongs to V1, V2 dash dash Vk minus 1, that is Vk belongs to V1, V2 dash dash Vk minus 1 for k is equal to 2, 3, dash dash n. Suppose Vk belongs to V1, V2 dash dash Vk minus 1, then Vk is a linear combination of V1, V2, Vk minus 1. Thus, the set V1, V2 dash dash Vk is linearly dependent, and hence V1, V2 dash dash Vn is linearly dependent. Conversely, suppose that V1, V2, dash dash Vn is linearly dependent. Consider the set S1 is equal to V1, S2 is equal to V2, S3 is equal to V1, V2, S3 dash dash Sn is equal to V1, V2, dash dash Vn. Then S1 is linearly dependent, and by assumption S1 is linearly dependent, we go down the list. Argue the first linearly dependent set, let Sk be that the set. Then Sk is linearly dependent and Sk minus 1 is linearly independent, as we have alpha 1 V1 plus alpha 2 V2 plus dash dash plus alpha k minus 1 Vk minus 1 alpha k minus 1 plus alpha k Vk is equal to 0. If alpha k is equal to 0, alpha 1 V1 plus alpha 2 V2 plus dash dash plus alpha k minus 1 Vk minus 1 equal to 0. But alpha 1 is equal to 0, alpha 2 is equal to 0, alpha k minus 1 is equal to 0. This given that V1, V2 possible, and hence alpha k is equal to 0, but then alpha k is linearly dependent, which is not possible, and hence alpha k is equal to does not equal to 0. But then alpha k Vk is equal to minus alpha 1 into V1 plus minus alpha 2 into V2 plus dash dash plus minus alpha k minus 1 into Vk minus 1. Vk is equal to minus alpha 1 upon alpha k into V1 plus minus alpha 2 by alpha k into V2 plus dash 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 plus minus alpha k minus 1 upon alpha k into Vk minus 1. Vk belongs to V1, V2 dash dash Vk minus 1. So this theorem is proved. Thanks to all of you.